All right, so I got this question on, this is from, let's see, section 1.7, example 7, and how to kind of translate this word problem into something you can solve. So you buy a bag of chocolates that costs $9.89 per pound. Okay, and the scale used to weigh the bag, let me switch to a different color here, is accurate to within, and it didn't copy over, it says 132 pounds. The bag weighs half a pound. There we go. Okay, so the scale is accurate within 132. So the scale weight, which I'll just say scale weight, could be higher by 1/32, or it could be lower by 1/32 of a pound. So let's just use variables for x to represent the number of pounds. So I'm going to just say x equals number of pounds. So whatever the scale says, it could be higher or lower by that amount. And so we can actually create an inequality here from this to represent that you're either higher or lower. You're taking the absolute value. When you have an absolute value inequality, you're basically saying the difference between something is less than or equal to some amount. So, and when we're looking at our absolute value, the difference between the scale weight and the actual weight, so I'll just call that AW. So that the difference could be, if the scale weight is overestimating, it would be a positive difference. If the scale weight is underestimating, it's going to be a negative difference. So if we take the absolute value, then we're going to get the number, the difference between the two is either going to be a positive or negative. But it's going to be accurate within 1/32 of a pound. So that difference should be less than or equal to 1/32, 1/32 x, basically. So that difference should be between that much. So that's sort of showing how the scale works and how you can use an absolute value there. So that difference between them, it needs to be under that threshold, basically. So according to the scale, the bag weighs half a pound. So the scale weight is, and since we're using fractions, scale weight is 1/2. Okay. And so, let's see, scale is accurate within 1/32 of a pound. So it's say, we could just, if we work with only pounds, we can just 1/32 of a pound. I think that's just 1/32. I don't think we need to have the x's there. It's just going to be within, if we just do everything within pounds. Okay, so the scale weight is 1/2 of a pound. And how much might you have been undercharged or overcharged? So we don't actually know what the actual weight is. So we know that the scale weight was half a pound, and we know that difference needs to be within 1/32 of a pound. So now we're solving this inequality. And this is an absolute value inequality. When you have the absolute value and it's a less than or equal to, you can create a compound inequality. So that difference is either going to be within 1/32 positive, or it's going to be a negative difference. The distance between the actual weight and the scale weight is going to be either a positive 1/32 or a negative 1/32. So now I have this compound inequality that I'm going to solve. So I'm going to scroll. And we're going to solve for the actual weight. So let's just make that a variable x. So we're going to solve for what is the actual weight of whatever the chocolates. So we need to have x in the middle. So I need to get rid of the 1/2. So I'm going to subtract. And actually, you know what? The easiest thing might be just to get rid of all these fractions. And we can do that by multiplying everything by 32. To get rid of that denominator, just so we don't have to worry about all those fractions. That's going to be much easier. I'm going to actually make this, there we go. So 32 times negative 1/32, we get -1. I need to distribute, so 32 times 1/2 is half of 32 is 16, minus 32x, because I need to also multiply that 32 by the x, and then less than or equal to 1. So now we don't have any fractions. It's going to be easier to solve. So I need to get the x part in the middle. So I need to subtract 16. And I'm subtracting it from, we have basically 3 portions here. So -1 minus 16 is -17, less than or equal to -32x. And then 1 minus 16 is -15. Okay. Now I need to divide everything by -32 because I just want a positive x. And when I'm dividing by a negative, when you're with inequalities, these have to switch directions. So those are going to end up in the other direction here. So we end up with 17 over 32 and 15 over 32. Now normally we write our inequalities so that the smallest number is to the left, so we can flip-flop this, and when you flip-flop, the inequality also changes direction. Again, just so everything is our normal direction. Okay. So the actual weight is either between 15 30-seconds of a pound or 17 30-seconds of a pound. So now we know the range of the actual weight. The question is asking how much might you've been undercharged or overcharged. So if it costs $9.89 per pound, we need to multiply our potential weights by the cost per pound to determine how much the charge would be. So that's $9.89 per pound. So I need to multiply the 15, let's see, I'll just do the 9.89, and since now, we'll just convert this, now we're going to be doing, let's see, this will be the cost. It's $9.89 per pound. We found the number of pounds needs to be between 16 and 17 30-seconds of a pound. And I'm going to actually just use my calculator to make these decimals because money is in decimal form. So I have 9.89 times 1532, so that's 4.64 when I round it. And then 9.89 times 17 divided by 32 comes to 5.25. So the actual cost should be somewhere between 4.64 and 5.25. So the question says, how much might you have been overcharged or undercharged? So your cost was $4.95. So I'll just switch colors again. Let's say, do purple. Now let's do green. So if your cost was $4.95, so if you paid $4.95 and the actual was 4.64, say the lowest possible, 4.95 minus 4.64, you could have been overcharged by 31 cents because that's the difference between 4.95 and 4.64. But if the actual cost was 5.25, then you have a lower cost, so you were undercharged. So you could have been undercharged by 5.25 minus 4.95, about 30 cents. So your cost ended up somewhere in the middle. You could have been overcharged by 30 cents roughly or undercharged by 30 cents. And that is the answer to the question. So you have to first try to translate it. You notice when I was initially trying to translate this, I had the x with the 32 and thinking x is number of pounds, and then I thought, well, wait a minute here. When it says it's accurate within 132 of a pound, it's not 132 times the number of pounds. It's literally 1 over 32 pounds. So that I don't need that. And so then I had to modify it as I started thinking through the problem. And that's sort of how you think about these word problems. But the setup here, this is a very common setup for anything where you need to have tolerance or you need to be within something. That's used a lot with manufacturing. So that is a very common use of absolute value problems, is when you know you have some measurement and needs to be within a certain tolerance. Chemistry does that. I mean, even if you're trying to predict something, you want your prediction to be accurate, so you may want it within a certain tolerance. So that idea is really important. So hopefully this is helpful, and let me know what you think. Bye.